the voltage for the CPU is always between 0.7 volts and 1.5 volts. Here we have the CPU control IC. Here we have the IC, the control IC. And then we have here two MOSFETs, Q1 for example, and Q2. Okay, here we have two MOSFETs. Then we have inductor. Okay, sometimes we can find a current sense resistor. Okay, we can find a current sense resistor. And then we have capacitor. The first capacitor, the second capacitor. Okay, and then we will get here VCC core plus VCC core. Let's assume that the voltage for the CPU is 1 volt, okay, or 1.1 volts. We need to get here 1.1 volts. So in order to generate this voltage here, the CPU will send some CPU IDs, about 6 or 7. So 1, 2, 3, 4, 5, 6, 7 IDs. We called it CPU, okay, CPU ID. This based on the CPU IDs, this IC we know the voltage for this CPU, okay. Then this IC will send a control signal for these two MOSFET. So this MOSFET is always connected with the output or the input, I mean with the B+. Let's for example assume that the B+ based in the motherboard that we have is 19 volt. Okay, so this B+ of course will pass through some capacitors. Usually this kind of capacitors is ceramic capacitors, and sometimes we can even find inductor in the input, inductor L. Okay, so those capacitors here, this is the CPU, the back of the CPU. Here we have this inductor, and this is capacitors. So inductor, capacitor. So this is the input, and here this input here is this one. Okay, and the output here, the output means this inductor. This is the output. Here we can check the output. Okay, so we have source connected. Let me please just draw these terminals, and then we have here source connected to ground. That's good. Here we have L, here we have R or PR. This is the current sense resistor. And I told you before that the current sense resistor, the purpose or the role of the current sense resistor is to measure and to sense the current consumed by the processor. When the CPU sends the CPU IDs, the IC, we know that this CPU is fed with 1.1 volts. So the IC will start generating the control signal to these two MOSFETs. Okay, the upper MOSFET and the lower MOSFET. Once these two MOSFETs receive the control signal from this IC, the 19 volt here, this 19 volts that pass through this path like this, it will then pass through this MOSFET, and then we will get here 1 volt, because this is a voltage regulator. Why we get here 1 volt? Here we have 19 volts and we get here 1 volt. Why? Because this is a voltage regulator, and based on this control signal, this is the signal that determine the voltage that we get here. Okay, we get here 1 volt. This 1 volt will pass through this inductor, okay, and then through the current sense resistor, and the 1 volt here will be filtered by these capacitors, and then we will get plus VCC core 1.1 volt to feed the processor. This is just one channel. We have another channel here that contains the same component. Now let's check the motherboards. Let's check in a real time the motherboard and try to locate these components in the motherboard. Always for any processor, you can find always the main channel. And for this capacitor that you find like this, if for example, if you find any of these capacitors failed, you can replace it with another capacitor with the same color and same size. But when you find a line of capacitor like this, you can even ignore the failed capacitor. If you ignore the failed capacitor, the circuit will work properly without any problem. Also here, do you see? We have these capacitors in the same line. Means this capacitor always in the same line, in parallel. Means, for example, if you find that this capacitor is bad, you can just remove it, okay, and just keep two capacitors. The circuit will work fine, no problem. But if you have the capacitor, don't hesitate to put it in its place. The CPU power circuit VCC core. So as you can see here, we have CPU power VCC core in page 10. So over here, as you can see, we have the IC. The IC, basically, this is a very big IC where we have, as you can see, the VCC. Over here, we have the VDD. Here we have the clock signal, the power good signal. And over here, we have the ID signals. We have here 7 IDs. As you can see here, we have V voltage ID, voltage ID 1 till voltage ID 6. So basically these IDs or these signals has as a purpose to determine the appropriate voltage for this CPU. Okay? So for every CPU it has its specific IDs. So based on these IDs, the IC can know the exact VCC core that should be generated. Okay? That's why we have these IDs. And of course, in the motherboard, you can find near to this IC this point. This is basically test point. As you can see, we have here TP means test point, where you can check this ID. So let me show you in the motherboard this test point. Basically, we have forehand and rear. We have 7 test points. So let's see in the motherboard. So as you can see, this is basically the CPU. Here we have the back of the CPU, and here this is the control IC for the CPU. Okay. If you focus here, we have max. Okay, Maxim 8770. The same reference as we have seen in the schematic. So, and over here we have the test point. As you can see, we have 1, 2, 3, 4, 5, 6, and 7. Okay, so here, as you can see, all these lines are for IDs. Okay, based on these IDs, this IC can know the specific or the exact voltage for the CPU. So this is basically the input voltage for every circuit in the motherboard, including the CPU circuit. So we have plus VBAT will be applied or passed through these ceramic capacitors. We have here 4 ceramic capacitors. As you can see, we have C1177, C1176, and so on. So all these ceramic capacitors has the same capacity and the same voltage. Okay, so we have 0.01 microfarad, and the maximum voltage for these ceramic capacitors are 50 volts. Okay, so the 19 volt will pass through these ceramic capacitors in order to be filtered, and then through this MOSFET, and then we will get here the VCC core, of course, after receiving here, as you can see, the control signal from this IC. This IC controls these MOSFETs, all these MOSFETs, okay? And then, of course, here we have inductors, as you can see, L19 and L13 in order to increase the current, okay? U1018. So let's see in the motherboard, in the back of the CPU, as you can see, we have U1018, as you can see. So this is the CPU control IC, okay? Then we have here 3 MOSFET, as you can see. So we have Q1042, Q1043, as you can see. Here we have Q1043, and this is Q1042. And here, as you can see, we have Q1044. This is basically Q1044 MOSFETs. So these two MOSFETs are these MOSFETs. And here, as you can see, we have 4 ceramic capacitors. This is basically the input of the circuit, where we have the plus VBAT. As you can see, these 4 capacitors has as a purpose to remove the noise for the circuit. So here we have C1177, as you can see, the first ceramic capacitor. As you can see here, C1177, this capacitor. Then we have C1176, as you can see, C1176, this one also. And we have other 2 ceramic capacitors, C1192 and 91, as you can see, C1191 and C1192. Okay, next to the CPU circuit. So 4 ceramic capacitors, we have 4 ceramic capacitors to remove the noise, and we have 3 MOSFETs, and here also we have 3 MOSFETs. Then, as you can see, we have inductor L19. So basically, we have inductor into the other side. As you can see, we have here L19, as you can see. So N19, L19. Okay. For the second inductor, as you can see, we have L13. This is basically L13, as you can see. And for the second channel, as you can see, we have Q1039. This is basically Q1039 MOSFET. Then we have Q1041 and Q1040. So here we have Q1040, and this one is Q1041. Okay, so this is all about the circuit, the CPU circuit. So here we have the CPU. This is the CPU IC. Here we have 3 MOSFETs for the first channel, and here we have 4 ceramic capacitors. Okay, for this channel, basically these 4 ceramic capacitors are just ceramic capacitors. Okay, and over here we have other 3 MOSFETs with 4 ceramic capacitors for the first channel. So 3 MOSFETs and 4 ceramic capacitors. So usually the failed components in the CPU circuit could be the IC, okay, so this IC, or MOSFETs, or this ceramic capacitors.